All right. You can see the board also, right? Last day we stopped the type of collisions. What are the collisions? Elastic collisions and inelastic collisions we discussed. That's in the under the elastic collisions. Those are the collisions which the kinetic energy during the collision is not change, right? It's remain constant. So it's elastic. That means when the both bodies collide, these bodies will deform and then they regain to its original shape without any residual deformation, the residue on the bodies. They come to the original shapes and then moving. So those are, because that means that kinetic energy will not be lost as the elastic potential energy. So that's why elastic collisions. In elastic collision, some part of kinetic energy will be lost. That's after the collision, kinetic energy is less than the that's the kinetic energy before the collision there. Those are elastic and inelastic. If you have two bodies when they collide, they combine together and they're moving as a single body, those collisions are called, that's a perfectly elastic collision, right? Perfectly inelastic collisions, right? Not elastic, inelastic. Always if some kinetic energy is lost, you can call it inelastic collisions. And also you need to know that in the perfect inelastic collision, that's the case with the maximum of kinetic energy can be lost. Okay, then today we will discuss some head-on collision, head-on elastic collision, because you have more in elastic collisions, and how to apply this theory for the collisions between the bodies like that, right? Okay, let's write this topic, the head-on elastic collision. To describe some head-on elastic collision. Head-on means that's head-to-head they call. That's in the after and before the collision, all the bodies are moving in the same. That's the center of mass of all the bodies. They are moving in the same line. That's we call the head-on collision. Head-on elastic collision. Okay. Right under that, first we write if colliding bodies before and after collision if colliding bodies before and after collision remain in the same line, remain in the same line if colliding bodies before and after collision remain in the same line, the collision is said to be head-on collision. Okay, this is Anisha. We start just now, right? So first write the topic, the head-on elastic collision, right? Under that, right, if colliding bodies before and after collision remain in the same line, the collision is said to be head-on collision. Collision is said to be head-on. Head-on එක මේව එක line එකේ තමයි පාඩේ. So okay, this will happen when bodies move along the line. This will happen when bodies move along the line joining their geometric centers. Along the line joining their geometric centers. Geometric centers. Then write separately, write as consider two bodies of masses m1 and m2. Consider two bodies of masses m1 and m2. m1 and m2 moving with velocities u1 and u2. Moving with velocities u1 and u2. Moving with velocities u1 and u2. u1 and u2. Then write within bracket, right, that's u1 is greater than u2. u1 is greater than u2, and then write along the same straight line. Along the same straight line. Okay, then write let after collision their velocities becomes v1 and v2 in the same initial direction. Let after collision their velocities become v1 and v2 in the same initial direction. Then draw this diagram. This is before collision, this is during collision, this is after collision. So those it is v1 and v2, masses are m1 and m2. Right. And during collision, the both bodies, last week we discussed this, both bodies are moving with the same, let's write the center of gravity, let's say somewhere here, so then it's moving the velocity during collisions. Then we are going to discuss this, how to apply these conservation laws for this curvature. Let's draw this one. That's a horizontal collision, that's all are moving in the same line. If this line is changed, so we need to consider when you consider about the momentum, you have to consider it in a particular direction. You can see the component of that velocity is also momentums you need to be considered. right, then right there, then according to the conservation of linear momentum, right, according to the conservation of linear momentum, as you can see in this direction I'm considering, right, that's a momentum before collision, that's equals to the momentum after collision. So linear momentum before collision, that's equals to the linear momentum after collision. It's a conservation of linear momentum discussed, right? So how we can write this? Linear momentum before collision in this direction, that is m1 u1 plus m2 u2. After collision, that's m1 v1 plus m2 v2. This one and this one, m1 v1 m2 v2, m1 u1 m2 u2. So this is the first equation, right? These all are in same line, that's why we are considering it is as a vector. You don't need to consider about the vector sign, then you need to use only the magnitude because the directions are same. And then I'll rearrange this equation, little rearrange. What we can do, the m1 terms take to the one side and m2 terms take to the another side. m1 terms take to this side as m1 times u1 minus v1, the v1 take to this side, m1 v1. m2 u2 take to the other side, then m2 take out, then v2 minus u2. It's easy, this will take as a first equation, this bit. I think it's over done. Okay, so since the collision is elastic, where we can see that's a kinetic energy after the collision, that's equal to kinetic energy before collision. Kinetic energy before collision, that's equals to the kinetic energy after collision, after the collision, right? So before the collision, that is half m1 u1 is the kinetic energy of the first part. Second one has half m2 v2 u2, sorry, and this is half m1 v1 square, half m2 v2 square. Half will cancel off, this all, and take the m1 terms to this side, m1 take out, then u1 square minus v1 square equals to the m2 terms to the other side, and v2 square minus u2 square. So take this as second equation. Right, this is m1, take this half will cancel off, this m1 v1 take to this side, and m2 u2 take to the other side, and m1 and m2 take out. This second equation you can get, right? I'll erase this thing. Okay. I'll erase this one, then I divide this second equation by the first equation and then write them. Okay, I'll erase. This one divide second one divide by the first one. Okay, then write there the first one, second one divide by first one. Then the second equation I have, that's m1 u1 square minus v1 square, and divide by the other side is m1 u1 minus v1. This side is m2 u2 square minus v2 square minus u2 square, m2 v2 minus u2. This is the way m1 m2 cancel, and this case you can write this u1 v1 u1 square minus v1 square is u1 minus v1 u1 plus v1, that is the difference of two squares. Here also v2 minus u2 v2 plus u2 divide by v2 minus u2. So this will cancel. So then remainder u1 v1 equals v2 plus u2. Take u terms to one side and v terms to another side. So you let me know the weights means, so I erase this or not. Is it okay? Should I want to write it again? Weight කියලා දැක්කේ දැන් මාර ටික මැකුවා. Right. I'm not erasing this part. Just okay, we got this equation. Now take this v2 to this side, that's u1 minus u2, and v1 to other side, that's v2 minus v1. The third equation. You can write this equation only for this elastic collision only, right? So what is this v1 u1 minus v2 u2? That is the velocity of this first body with respect to the second body. So okay, so we call it the velocity of approach, that's the relative velocity of approach, and this is the velocity of the second body with respect to the first body, that is the relative velocity of separation, because before the collision they approach to each other and then collide. After the collision they separate to each other, then they are separation, because if not then again it's collide. This cannot be happen, right? So it's important relation then, this third one, right? So I'll erase this, so you can write up to this point and let me know if you finished the writing. Raise your hand if you finish the writing, right? If not, I don't know whether you will finish or not. Alright. Then after that point you can write thus velocity of m1 with respect to m2 before collision. You can write then thus velocity of m1 with respect to m2 before collision is equals to the velocity of m2 with respect to m1 after collision. This third relation is interpret like, right? So it means you that's velocity of approach, that's equals to the velocity of separation. Velocity of approach is equals to the velocity of separation. In the case of elastic collisions only you can write. the elastic collision, you can write like this: velocity of approach equals to the velocity of separation. Okay, now using these three relations, actually third equation and the first equation, we can subject what are the velocities after the collision in terms of the velocities before the collision, right? If you finish the writing, let me know. I will erase this all and then write it. Raise your hand if you finish, because we come to the final. There's a small thing we need to discuss, because we are not going to discuss this all types of collisions, because there are oblique collisions and other collisions are also there, so little different. We will discuss some things about the collision related to this manner only, right? Okay, right. I'll erase this right now. Right. Okay, could you remember the first equation? මතකයිනේ. first එක මම මෙතන මැකුවා ඒක හරි. ඒක තමයි මේක ලියන්න ඕනේ. From this third equation, I'll subject, because I want to find V1, so I subject V2 and substitute in the first. Here V2 you can write from this equation, take this V1 to the other side. It's U1 minus U2, that's plus V1. Okay. This is, let's see, fourth one, and then fourth one substitute in the first one. I'll erase this equation also. Now this is substituting 4 in 1. So then you can write in first take the M1, there is U1 minus V1, so other side is M2 V2 instead of V2 you can substitute this U1 minus U2 plus V1 minus U2. Then subject this is M1 U1 minus M1 V1, this M2, this is U1, and they are minus U2 minus U2 2U2, this minus 2U2 M2U2 to M2U2, and this V1 also there, that's plus M2 V1. Okay, take this M1 V1 to this side, and then take the other, send all the others to the other side. So I will write is this side, and if M1 V1 goes to this side and then V1 take out, so you can write this and M1 plus M2 times V1. මේක මේ පැත්තට ගේන්න. එතකොට මෙතන U1 take out, that's M1 minus M2, take U1, and this also goes to the other, plus 2 M2 U2, and then V1 you can subject. V1 is equals to the M1 minus M2 divided by M1 plus M2 times U1 plus 2 M2 divided by M1 plus M2 times U2. This is the fifth equation. So then in this V1, that's the velocity after the collision, they are saving in terms of U1 and U2. Same way you need to do this for the V2 also. Then if you want to find V2, what you need to do, then subject the V1 here and substitute there, this V1, and then you can find the terms V2 in terms of U1 and U2, because we are going to find this all the terms after the collision in terms of the quantities before the collision. That's the way. First you write there, then try to write this V2 and let me know. V2 ලියන්න ලියලා පුළුවන් නම් මට ෆොටෝ එකක් දාලා එවන්න ඔයගොල්ලෝ ගත්ත එක්ස්ප්‍රෙෂන් එක. I will check it and I will tell you is it correct or not. මොකද ඔයාලා වැඩ කරන්න ඕනේ. මම ලියන එකම ලියන් හිටියයි කියලා ඇති වැඩක් වෙන්නේ නැහැ මොකද විභාගෙ. So I will after finishing this part then I will start your class physically. I think now it's okay. We'll start the class physically after this particular. Next part is we have to start the angular motion, right? The circular motion part. From that part I will start from physically, right? So it's better, or if you have any difficulty let me know. So I intend to start the class physically. Is there any date and time other than Sunday? ඉරිදාට වඩා වෙනස් ඔයගලන්ට පුළුවන් දවසක් තියෙනවද පන්ති ගන්න? කියනවනම් මට group එකට message එකක් දාන්න කී දවස කියලා. ඒකට මේ පන්ති අපි ඉදාට change කරගමු ඕන. ඒකෙම ඔයගලන්ට physically එන්න අමාරු නම් අත් මට කියන්න බොරුවට මේ. ඔයාලට අමාරු නම් මම physically ඇවිල්ලා වැඩක් නැහැ. ඔයගොල්ලන්ට මං හිතන්නේ physically කරොත් හොඳයි කියලා. ඔයාලට ලේසි online කරන විදිහ නම් I don't care about that. weekdays වල evening ඔයාලා ඉස්කෝලේ යනවනේ මේ දවස්වල. ඉස්කෝලේ ගිහිල්ලා එනකොට කීය විතර වෙයි? දැන් එහෙම නැත්තම් පටන් ගන්න වෙන්නේ රෑ. ඒ කියන්නේ අපි 4 5 6 6ට පටන් ගන්න රෑ 9 විතර නිකන් අම්මලට එක්කන් යන්න ඉන්න පුළුවන් ඒක. එහෙම නැති වුණොත් 3 විතර ඉස්කෝලේ යන්න ඉන්න පුළුවන් 3 වෙයි. මටත් එන්නේ 3 විතර වෙයි. මම මේ ඉඳන් එන්න බෙදාලා. ඔයාලට ප්‍රැක්ටිකල් කරන්න විදියක් තමයි ඊට පස්සේ හදාගන්න ඕනේ. ඒ කියන්නේ ප්‍රැක්ටිකල් කරන්න විදියකුත් ඊට පස්සේ කියන්නේ මට I can write the instruments and lab setups everything to do the practicals. The problem is that I will ask that live faking අහලා බලන්න. සමහර සෙට්ස් තියෙනවා දැන් ඔය පැරලෝගම් බෝල් එකේම කරන්න තියෙන සෙටප් එක බිත්තිය ගෙල්ලන්න ඕනේ. එතකොට බිත්තියට බෝල් ප්ලග් දෙකක් අහලා එහෙම බිත්තියක් හදා ගන්න ඕනේ. ඒක එල්ලලා තියෙනවා. එල්ලන්න ඕනේ ඇවිල්ලා කරන්නට. සමහර ලොකු ඉන්ස්ට්‍රුමන්ට්ස් තියෙනවා ඒවා සංගෙන් ගියාම අමාරුයි. එහෙම නැත්නම් if you can come to my place, my home, එක දවසක දාලා ඔය ප්‍රැක්ටිකල් කිහිපයක් ඒකට කරලා යන්න පුළුවන් මොනවා කියන්නේ arrange it at ඔය holiday එකක වගේ කියන්නේ foyer එකක හරි in the morning set කරගත්තොත් ඒ practicals ටික කරලා යන්න පුළුවන්. මම හිතන්නේ එහෙම තමයි වඩා හොඳ. මොකද practical setups ආරම්භයෙන් එහෙ එන්න ගියොත් හදිස්සි හරි මට මොනවා හරි එකක් අමතක වුණොත් එහෙම දැන් ගෙදරදී නම් මොකක් හරි හොමේ ඕනේ වුණොත් මිටියක් හරි හොයාගෙන ගහන්න පුළුවන්. අර වගේ වෙලාවක අමාරු වෙනවා නිකන් හරි අමතක. I will discuss it with you because practicals එහෙම කරන්න පුළුවන් because මේ mechanics lesson එකේ all the practicals we can do and also in the wave lesson all the practicals we can do. So I have all the setups I can provide. So in light lesson ekit but only the spectrometer I don't have, but I try to buy one. But nowadays there's a problem with the dollars, no? So then they can't import can't bear me. ඒක තමයි problem එක තියෙන්නේ නැත්තම් එකක් ගන්න තිබ්බා. Spectrometer is just only one practical, so but other practicals I can provide. Then we will try to do this out. Let's see. Okay, what is the V2? We'll discuss later about this, right? How to do the practicals and how to do the future class. So I think it's better to do physical. I think you also agree with me. For them physically, I can monitor you, and other one is then I have planned every day. Now we already know about the theory, no? Theory goda then I have planned the future class. Every day after the lesson, we'll give some feedback as small questions. Exam එකට යනකන් දිගටම මෙහෙම හැමදාම ප්‍රශ්න කිහිපයක් කරන්න. Small MCQs and එතකොට අපි දැන් තමයි සූදානම් වෙන්නේ. දැන් අවුරුද්දක්ම වගේ කියන්නේ next exam එකට you have to be prepared. දැන් ඔක්කොම method දැන් ඔයගොල්ලෝ මේක exam syllabus යන විදිය දන්නවනේ. ඊට පස්සේ අපි exam එකට focus කරන් යන්න ඕනේ. Right? I will make it by doing some extra thing. So we have to every day we have to write some answers for the questions. I will give the structured equations, MCQs, and essay questions. එක D එකකට නිකන් just හිතාන දවසකට එකයි essay එකකුයි එකයි structured එකකුයි අපි 10 MCQs කරා කියමු. එතකොට ඊළඟ අවුරුද්ද වෙනකොට අපි ගොඩක් කරලා තියෙන questions. papers කරා වගේ තමයි. Okay, let's. මොකද V2 වෙන්නේ? So what you do to the V2 then? This V1 here. V2 then V1 subject කරනවා නම් මේ ටික ගෙනියන්න ඕනේ මේ පැත්තට. I will write this V1 equals then this V2 here this U2 minus U1. කොහොම තමයි? Now substituting this one මේක මොකක් හරි Roman number එකක් ගමු මොකක් හරි වෙන එකක් 4 dash කියලා මම කියනවා. හරි. ඒක අරකෙම හින්දා මේකේ substitute කරන්න මෙතන. V1 මෙතනට substitute කරා. That's M1 මම මේ ආයෙ ලියනවා මකලා. 1 minus instead of V1 you can write this U2 plus U1 minus V2 and this side this is V2 minus U2. All right. Wednesday and Friday දාලා තිබ්බේ ඒක ඔක්කොටම අනිත් දෙන්නට පුළුවන් ද Wednesday Friday එහෙම කරත් ඒ කියන්නේ Sunday නැතුව Wednesday Friday දැම්මොත් Wednesday or Friday evening. Okay, my දවස්වල nowadays I have a class at that time, but future means that after this A level exam I can arrange those the days. මොන දවසක arrange කර ගන්න පුළුවන්. ඒකකම් මට මොකක් හරි විදියකට එක කරන්නත් පුළුවන්. It's okay. අනිත් දෙන්නට පුළුවන් නම් it's okay. Then I can advertise. Wednesday තමයි better. Friday වලටත් වඩා මොකද Friday I also have a class. Right, here then I am V2 subject කරමු. මෙතන ready කරාම එන M1 minus U2 V2 goes to the other side. Here M2 U2 takes to this side. So now I write this M1 plus M2 times V2. මම එකපාර ලියනවා මේ ඉඩ මෙතන සීමිතයි. ඒ ඔයාලා මේක එහෙට මෙහෙට කරලා V2 එක පැත්තකට ගන්න ඉතුරු පද ටික අනිත් පැත්තට ගන්න. හරි. ඒතර හරි. m1 u1 මෙතන u1 u1 u2 that's 2 m1 u1 then ඊට පස්සේ මේ කාර පැත්තෙන් හිටිනවා plus m2 minus m1 u2. So then the v2 equals 2m1 divided by m1 plus m2 u1 plus m2 minus m1 divided by m1 plus m2 u2. This is 6th. Alright. This is the way I will write this two equation we obtain. ඔච්චරයි. ඕක මම මේ පොඩි රිසල්ට් එකක් ගැන කියන්න ඔය දෙක ගත්තේ. දැන් ගානක් හදනකොට මේ ඔක්කොම ලියන්න අවශ්‍ය නැහැ. ඔයගොල්ලන්ට මේ ගානට කෙලින්ම values එක දැම්මම you can simplify and get there. That's why I'm practicing here you how to apply those equations. That's right. With the symbolic form I will write those all, but it's even numerical values it is easy than this, because simply you can simplify. Okay, then this results the v1 we write as m1 minus m2 divided by m1 plus m2 times u1 plus 2m2 divided by m1 plus m2 u2. This is the fifth equation. The sixth one is now this one. These are the results we obtain. Okay, these two equations we obtained, right? Now let's see. I will erase this all, right? These two equations are remain there and others. This unique, you can do this, right? Employ kala oyala liyanna ඕනේ. ඒකට ඔයගොල්ලෝ දන්නවා how to get it, right? Then we will consider about some special cases using this, the special cases of the collision, right? The special cases. Peter ගන්න පුළුවන් හොඳ relations ටික. First case I consider the when colliding bodies are of equal masses. This case we write when colliding bodies are of equal masses. Of equal masses. Okay, then we can consider that let m1 equal m2, that's equal m. Those are equal. Then the equation from the equation 5, number 5 equation, this m1 m2 equal, this part becomes 0. If m1 equal m2, this is 2m, this is 2m, 2m 2m cancel, then u2. So then the v1 equals u2 from the equation 5, and from equation 6 you can write this part becomes 0 and this will become 1 then. So then v2 equals u1. So it's a fantastic relation happened. What happened there? Their velocities are interchanged, right? There's the initial velocity u1, that is the body of mass m1 before the collision. So it's transferred to the second body velocity, and the velocity before the collision of the mass m1 mass m2 it's become the velocity of the mass m1. So that means the velocities are interchanged. If two masses, that is AB, having the same mass, when they collide, this is velocity u1 and this velocity u2, and after the collision the same mass, that is AB, this is the velocity v1, this is velocity v2. The v1 becomes u2, v2 becomes v1. So their velocities are interchanged after collision. That's happened. That's you need to keep the mind in when you write in the mass. That's the MCQ questions. You don't need to prove it. You can directly use that. If two masses are equal, so when they collide, their velocities are interchanged. As a further we discuss this, if let's say the body B remains as u2 is 0, then what happens? Their velocity interchange means this becomes 0 velocity and the B becomes the velocity of the A before collision. So that means if the body is at rest and the other body will come and hit with the velocity u, then after the collision, this is A and this is B, then after the having the same mass, right, elastically collide in head on. So after the collision, what happened? The A will be stopped and B will moving with the velocity u. Have you seen any practical that's phenomena? If this happen, we can say in a carom board or in a billiard board, snookers වලදී මෙහෙම වෙනවා. ඒවා equal masses තියෙන්නේ. අර එකෙත් එක්කෙන් අනිත් පිටට මෙහෙම අල්ලන. ඒවා හරියටම head on එකටම මෙහෙම හරි කෙලින් වැදුනොත් ඒ එක නැතර වෙලා අනික යනවා. දැන් ඔය කැරම් බෝඩ් එකේ ඉන්නේ එකෙත් එක්කෙන් අනිත් පිටට අල්ලලා මෙහෙම අපි අර එකෙන් අල්ලලා අනිත් පිටට ගහද්දි ගොඩක් යාට දැක බලන්න වෙන්නේ. ඒ ඉත කියලා එතන නැතර වෙනවා. අනිත් එක යනවා ඉස්සරහ. Because we can consider it as elastic collision because the friction is very low there, because we use some powders there. දානවනේ අර boric powder. ඒතකොට ඒවට friction අඩු වෙලා යනවා. ඒ හින්දා elastic කියලා හිතන්න. ඒක අර එහෙම නතර වෙන්නේ නැතුව move වෙන්නේ head on කළ ඇයිඩුන් නැතුවම angle එකකින් වැදුනොත් එතකොට ඒවා directions වෙනස් වෙලා යනවා. Right. This radiation holding. This is right. එතන මෙහෙම ලියා ගන්න පොඩි වාක්‍යයක් විදියට, as a sentence you can write there. Put it and right there, it's better. Hence, when two bodies of equal masses, collide elastically, their velocities get exchanged. This A and B, this is A and B. You can write this in this way: u1, this is u2, and after collision this become u2 and this become u1. This is before and after. If you want, you can draw it and show. Then if u1 u2, if same masses they collide, I don't call it, that's elastically, and then u1 and u2 exchange. Then the second special case, the same thing, but one is stationary, P is stationary. That's m2 is equals to m, and the u2 equals 0. u2 equals 0. Then this second case is this one body has stopped there. So then what's happened? This v1 becomes 0 and then v2 become u1. That's a moving body gets stopped, then the stationary body will move with the velocity of the moving one. Right. Their velocities also exchange. This is moving with the velocity u1, let's say. This is A, and the B is initially 0. So this is before the collision. Keep those in mind. This is easy way. After the collision, this is same mass. Masses may condition satisfy when that one. So this becomes stop then, right? And this is moving with the velocity u1. This is after the collision. In this case, this is happened for equal masses of bodies. All right. Okay, I will erase this one then. Do you want to know? It's okay. Okay, then write the third special case. Write that one. When a lighter body collides with the massive stationary body. When a lighter body collide with a massive stationary body. Lighter body collides with a massive stationary body. So lighter body means that's a small. Let's say thus we can say that's M1 is much smaller than M2. The one body is lighter than the other, and that's one body is stationary, massive one is stationary, so that M2 is at rest. Right. Then that equation number 5. Before we come to the 5, let's say if M1 is much smaller than M2, that's M1 plus M2 approximately equals to M2 only, because it's massive. The other one is negligible. And that's M1 minus M2 minus M1, or that's also approximately equals to M2. If M1 minus M2, it's minus M2, right? And also we can say that since M1 divided by M2, if smaller one is divided by the larger one, that's a 1 kilogram divided by 1000 kilogram, let's say, it's approximately equals 0. So using the equation number 5, then you can write under this case, here is V1, what's happened, M1 minus M2 is equals to minus M2. M1 plus M2 is equals to M2 and U1, and here that's 2 M2, that's approximately equal to M2, that's U2. Here this part is 0 because it is initially U2 is 0, right? So then this M1, M2, M2 to cancel, this is minus U2. So that's V1 equals to minus U1 there. And in the equation number 6, this V2, how you get the V2? Yeah, this is 0 according to this relation, and this part is already 0, so the V2 is 0. That means the second body remains as rest. Graphically again, smaller body and this is large body. There is M2, this is M1. When it's moving the U1, this is stationary. This is before, I write this AB, that's before collision. Then after collision, make him make a වැදිලා අනිත් පැත්ත. Minus U means අනිත් එක එයා වැදිලා එනවා මේ පැත්තට. U1 give me. මෙයා එහෙම වෙන it's not change. ඒ ස්ටේෂන් ඒ විදිහටම තියෙනවා. අනේකෙන් ඔයාලට ගන්න තියෙන මෙච්චරයි. ලොකු විචාරිත heavy mass එකක small එකක් ගිහලා නිකන් negligible mass එකක් ගිහලා collide වුණා. ඒක rebound වෙනවා. head on collision එකක් වුණොත් හරි. This will get rebound. After this point you can write there, hence when light body collides with a massive stationary body, hence the light body collide with a massive stationary body, the light body rebounds after the collision. Light body rebound after the collision with an equal speed. While the massive body remains at rest. Hi. Okay, then write the fourth special case, other way. That's when a massive body collides with a light body at rest. So then write fourth one, when a massive body collides with the light body at rest. When a massive body collides with the light body at rest. That case you can write thus the m1 is much greater than m2 and u2 is at 0. I'm considering, right. Then that's m1 plus m2. This is much larger, so approximately equals to m1. m1 minus m2, that's approximately equals to m1 also. And then m2 divided by m1 or m1 plus m2 is approximately 0. This m2 is much small, then that's it, right? So, and from the equation 5, then you can write this is m1, this is m1, they cancel this u1, it's equal. Other part is 0, right? Because u2 is 0, this part also 0. And then v2, what's happened? From the equation 6, this is from 5, and this become 2 m1 and m1 plus m2 is also m1, m1 cancel, and this become 2u. It's much amazing results, right? So if a larger body will move with the velocity u1 and collide with the smaller body which is at rest, so this before collision, this is the situation. And then after the collision, that's m2 is moving with the same velocity, that's m1 is moving, its velocity will not change, it's moving with the same way, and smaller one moving with the velocity of twice the velocity of the ball, that's a larger ball, 2u1, so it's moving, so it's after collision. Make an experience can't pull on. Take a basketball and place a tennis ball on it and hold it like this. දෙක එකට තියලා අල්ල ගන්න. අල්ල පොඩක් බීමට මෙහෙම ආයෙත් මූණ ඈඩ් කරලා තියලා දෙකම එකපාර මෙහෙම අතාරින්න. දැන් මේක බිම ගිහිලා මේක වදිනවා. මේ දෙන්නම එකම විදිහට යනවා. මේක වැදුනාම දැන් this is relatively stationary. This body මේක rebound වෙන බිම වැදිනවා. ඒක move වෙලා වදිනවා. ඒකට මොකද වෙන්නේ මේක ඒ velocity එකෙන් උඩට එනවා. මෙන්න මේක අර වගේ 2 times velocity මේක එකපාර නිකන් අපි හිතා ගන්නත් බැරි විදිහට එකපාර උඩ යනවා ශරීරය. රුස්සා. But you can see it. Okay, ලියා ගන්න. හරි ඔය රිසල්ට්ස් ටික තව ඔයා ඕන තරම් එක ඒවා කියන්න පුළුවන් අරක මේක මෙහෙම කියලා. Basically you need to know that's what's happened. in these kind of systems, right? When two bodies collide, this one is larger, other is smaller. So how those results happen, right? You can write the equation and get that values. And if one body is much larger than the other body, you can take that m1 plus m2. By that smaller body, you can neglect this. If two bodies are in the comparative masses, you cannot neglect, right? So then energies and other things we discuss, and I'll discuss another one, another collision, that's a perfectly inelastic collision, right? So you can write there perfectly inelastic collision, because inelastic collisions we are not discussing in your syllabus, because it's some part of energy transfer, that's Newton's experimental law you need to consider, but that's not in your syllabus. That is in the mathematics syllabus. Mathematics වලට තියෙනවා ඒ ටික. හරි. So first write perfectly inelastic collision. That perfectly inelastic means, last week I given you that definition, that is, if two bodies after the collision, if two bodies stick together and moving as a single body, or combine the two bodies and they're moving, so we call it a perfectly inelastic collision. That's the maximum kinetic energy is lost in that kind of collision, right? You write there, let's write under this. Consider two bodies of masses m1 and m2. Consider two bodies of masses m1 and m2. Two bodies of masses m1 and m2 moving with velocities u1 and u2, moving with velocities u1 and u2 along a straight line, along a straight line. Right, they make a perfectly inelastic collision. They make a perfectly inelastic collision. Right, let after collision, their common velocity becomes v. Their common velocity becomes v. Then by conservation of momentum we can write, okay, then by conservation of momentum we can write the equation as below. You can first consider these two bodies, that is m1 the mass and other is m2 the mass, moving the velocity u1 and u2. So that's before collision. And after collision, these two bodies stick together, so they're moving as a single body. Yes. Now the mass is m1 plus m2. So after collision, we can apply the momentum, that is a linear momentum conservation, LCM. We are applying, right? I'm writing in short form, that's LCM, linear momentum conservation, in right word. So initial, before the collision, that's a linear momentum before collision. That's equals to the linear momentum after collision. If you don't know that's Lm, you can write it linear momentum, right? This is m1 plus u1 times m2 u2. So keep in mind, if this one body අනිත් පැත්තට යනවා නම් if it comes towards the other one, this should be negative. According to the same direction, you can write this as possible. And then after the collision, the total body mass is m1 plus m2, moving the velocity v. So then the velocity after the collision is equal to the m1 u1 plus m2 u2 divided by m1 plus m. So this is the velocity after collision. So you don't care about the kinetic energy because the kinetic energy will not be remain constant. If some kinetic energy will be lost, then you can find the kinetic energy lost during this collision. Okay, then they write the loss in kinetic energy or loss of kinetic energy during the collision, right? Loss of kinetic energy in collision. You can write as kinetic energy before the collision is half m1 u1 square plus half m2 u2 square minus after the collision, that is m1 plus m2 plus v square. You can write, you simplify for this for u square, that's v square, and then simplify. Simplify, you can get this equation, try to get it. If you couldn't get, let me know, then I will simplify step by step, but here I will write it in that form. Is that's half m1 m2 divided by m1 plus m2 times u1 minus u2 square. ड्राइव करने के अच्छा ने कानकदी ඔයගොල්ලන්ට values දාලා substitute කරගන්න පුළුවන්. මේවා නිකන් mathematics විතරයි ඒවා ඇත්තට හිතන්න එපා. මේ වගේ decision එක ගන්න පුළුවන්. So you can calculate. So this loss of kinetic energy, that's will appear as heat or sound because that's converted to the different form of energies, not the mechanical energy, right? After that you can write that also the loss of kinetic energy loss of K will appear as heat or sound. Loss of kinetic energy will appear as heat or sound. All right. Do you have any questions up to this point? You can ask. I'm going to discuss some examples. Write an example. Then first one, 8 kilogram ball moving with velocity 4 meters per second. 8 kilogram, right? 8 kilogram ball moving with velocity 4 meters per second collide with 8 kilogram ball moving with the velocity 4 meters per second collides with a 2 kilogram ball moving with a velocity 8 meters per second. 2 kilogram ball moving with a velocity 8 meters per second in opposite direction. 8 meters per second in opposite direction. If the collision be perfectly elastic, what are the velocities of the ball? What are the velocities of the balls after the collision? Velocities of the ball after the collision. This is the first one. And write the second one. Second one, right? Two identical balls marked B and C. In contact with each other and at rest on a horizontal smooth surface. Are hit head on by another identical ball. By another identical ball marked capital A. Moving initially with speed V. As shown in the figure below. Right? If collision is elastic, then which of the cases are possible? එකක් මේකේ අවස්ථා තුනක් තියෙන. මේ තුන possible වෙන්න පුළුවන් ටික reason එකත් එක්ක කියන්නයි. These are the 3 cases, right? In the first case, A is stop, and these both are moving with V over 2 the velocity, B and C. V over 2, right? V divided by 2. In this case, these two are stationary, and the C moves with the velocity V. In this case, that's A, B, C all stick together, and they are moving with the velocity V over 3. Which of the cases are possible during these three? Out of these three, you can calculate and tell me, and with the reason. Okay, these two questions I'm given you. First you do this, and next we'll discuss the others also. පළවෙනි එක මොනවද එන්නේ උත්තර? After the collision, what are the speeds of the two bodies? I'm මේක මකන්න නැතුව මේක මකන්න නැතුව තියන එක ඊළඟට ඕනේ. This is A plus 1. 8 kilogram ball is moving the 4 meters per second, right? And a 2 kilogram ball moving opposite 8 meters per second. They collide. This is before the collision. Before collision. Now after the collision, asking the velocities. I'll consider that's after collision, the both are moving v1 and v2 same direction. This is after collision. Let's apply the momentum conservation, the linear momentum conservation to this direction. Before the collision, 8 into 4 plus 2 kilogram into the 8, it is minus 8. It's not in the direction we consider. That's minus 8. And after the collision, the 8v1 plus 2v2. Then you can divide this by 2, and then this is 13 and 16, and this is 16, 32, 60, 16 divided by 8. So you can write that is 4v1 plus v2 that's equals to 8. That's the equation you can use that. If the collision is elastic, so then you can use the kinetic energy concept. Kinetic energy is a constant because the collision is elastic. So then the kinetic energy is half the mass of 8, and v square is 4 square, and plus half initial kinetic energy, 2 into 8 square, and this one half 8 into v1 square plus half 2 into v2 square. එම ස්ක්වයාර් තියාගෙන සිම්ප්ලයි කරන එක ටිකක් ඩිෆිකල්ට්. හරිද? ඒ හින්දා මේක දැන් මම අර මම ප්‍රූව් කරපු විදිහට සිම්ප්ලයි කරාම ලේසි. So I will simplify this in the other format, right? මේක ලේසියෙන් කරන්න පුළුවන් විදිහට මම සිම්ප්ලයි කරලා කියන්නද? ඒක වඩා ලේසියි. මේක අර එක මාස් එක තියෙන එක මේක පැත්තට ගන්න. Easy for you. 8 kilogram, 8 kilogram. You take this to this side. So then you can write as 8 එළියට ගත්තාම v1 minus 4. මේ ටික එහාට ගත්තා ඒකත් එක මෙහෙට අරන් ඉන්න. So එතන මෙතන 2 kilogram එළියට ගත්තාම minus මනේ minus 2 එළියට ගමු. That is 4 plus v2. මෙන්න හරි එහෙම ගන්න ඉක්වේෂන්. ඉතින් ලේසි. මේකත් එහෙම ගන්න. මම මේක මේ half එකකින් කැපිරෙනවා. cancel out. මේක මම මෙහෙම ගන්නම් මේ ඉක්වේෂන් මෙතන ලියන්නම් උඩි. මම මේ රූපේ මෙහෙම තියාගන්නම් මොකද ආයි අඳින්න ඕනේ නැති හින්දා. එතන මේ දෙකෙන් බෙදලා ගන්නත් පුළුවන්. ඔහොම තියෙද්දි ගන්නත් පුළුවන්. That's v1 minus 4 that's equals to the minus 2 4 plus v2. That's the equation. මේකෙත් එහෙම ගන්න. මේකෙ මෙන්න මේ v1 මේ පැත්තට ගන්න. මේ 8 මේක එහා පැත්තට ගෙනියමු easy. 8 take out and then v1 square minus 4 square. එතන 2 kilogram එක මේ පැත්තට ගත්තොත් 2 take out, that's 8 square minus v2 square. Second one. එවදී බෙද. එතකොට second divide by percent. මෙතන එනවා v1 square minus 4 square. So v1 minus 8 capital එනවා. මේ පැත්තේ එනවා minus 8 square minus v2 square divide by මෙතන පොඩි ඉස්සුළු කිරීම මෙතන 8 ඉන්නේ. මෙතන 8 නේ තියෙන 8. නැත්තම් මේක මොම්බල කැපෙන්නේ 8 සෝසිද 8 plus 8. දැන් මේක බෙදුවාම හරිය මෙතන v1 minus 4 v1 minus 4 cancel remainder වෙන්නේ මෙතන v1 plus 4 විතරයි. මේ පැත්තේත් එහෙමයි. මෙතන ඉතුරු වෙන්නේ minus 8 minus v2 කියන එක විතරයි. So you can get the relations between them. That's v1 minus v2, that's equals to the minus 12. That's another equation. Okay. So මෙතන එනවා මම එක ගන්නම්. That's equation number B එක. දැන් මෙතන simplify කරලා ගත්තාම ඉස්සෙල්ලා මම අර ආපු equation එක එනවා. That's v1 v2 අතර relation එක. That's 4 v1 plus v2, that's equals to the 8 here. 8 to 60. ඒක ගන්න ඒ equation. ඒ දෙක සුළු කරලා ගත්තා හැකියි. If we add these together, හරි නේද? හරි ඔයගොල්ලන් මේ රූපේ හින්දා පොඩ්ඩක් අපහැදිලියක් ඇති. මේ ටික මෙහෙම කොටු කරන්න. ටික ඊළඟට මෙතනින් ගන්න ඉක්වේෂන් එක මේක එනවා. මේක මේ විදිහට මේ දෙක බෙදලා ගත්තාම මේක. So then you add these together, a and b. මෙහෙන් ලියන්න you can මාත් එක්ක ඔයගොල්ලෝ ලියාගන්න. a and b add together. So මේ දෙක එකතු කරාම එනවා v1 minus v2 මෙතන මේ minus v2 plus v2 cancel. So මෙතන v1 plus 4v1, this is 5v1. එහා පැත්තේ එන්නේ 16 minus 12. That is 4. That's v1 equals 4 over 5 meters per second. Substituting it in the that one equation there, you can find the v2 there. So v1 is 4 over 5. Negative sign එකක් එන්න ඕනේ. මොකක් හරි. එකක් නෙගටිව් වෙන්න ඕනේ. එකක් කොලයිඩ් කරාම දෙන්න දෙපැත්තට ආයන්නේ. මම එමෙ නැත්තම් අතන එකක් හොයලා ඒක අරකට දාලා quadratic equation එක කරන් it's difficult let. Okay, I'll rest check. මේක ආපු හැටි මම කියන්න. ආයෙ මුලින් ඉඳන් ලියලා පෙන්නන්න. මේක විතර චාරු වගේ පේන්නේ නැති හින්දා. I'll erase this and write then, right? මම මේ ඔය උත්තර ටික මේ රූපය ඔහොම තිබිච්චාම මේක මම මකලා යන්න දෙන්න. So one by one and then okay, then this is the case, right? You apply the momentum conservation, right? That's applying momentum conservation to this direction. Then initially this one has the 8 kilogram into 4 plus this is the opposite way it is moving, that's 2 into minus 8, that's these two are taking as same directions moving, that 8v1 plus 2v2, right? Right, then make it mangana mena meka me patta, so then the 8 take out 4 minus v1 මේකද එහා පැත්තේ එක plus නේ, minus 16 goes to the other side, the plus, the 2v2 the 2 take out and then v2 plus 8. That is the first equation I have. And මේකෙම මම ගන්නවා v2 අතර relation එක. මේක බෙදලා දැම්මම this 2 into cancel, this 4 into 4 is 16 minus 4v1, that's multiply v2 cancel now, v2 plus 8, that's v2 plus 4v1 18 නේ. මම ඉස්සෙල්ලා නෝ සිම්ප්ලයි කරපේ වැරදිනේ 16 යා එහෙම එකක් හරි. Yeah, it's 8 but it's not v2 minus v1, it's a v2 plus 4v1, right? Then use the kinetic energy conservation, because the kinetic energy is constant for elastic collision, the given that is elastic, and then the energy half into mass is 8 and into speed is 4 square, and the second body half the mass is 2 and speed is 8 square, and after the collision half the mass is 8 and v1 square plus half the mass is 2 and v2 square. Half will cancel this all, right? Half in the 8 4 square, this is an 8 v square. I will take this side, 8 take out, that's 4 square minus v1 square, and then make මේ පැත්තට ගෙනියන්න 2 එළියට ගත්තොත් the v2 square minus 8 square. This is a third equation. Now divide this third one by first one, then this 8 and this 8 cancel, and this is a 4 square minus v1 square, divide by 4 minus v1. This side is v2 square minus 8 square, divide by v2 plus 8. So make a square difference of 2 squares, 4 minus v1, other bracket is 4 plus v1. 4 minus v1 cancel, this 4 plus v1 remain. Here also the v2 plus 8 cancel, then v2 minus 8 remain there. So here it's equals to that v1 minus v1 plus v2. I take v2 to this side, 8 to other side, it's equals to 8. The fourth equation. Now okay. Now these two we can solve. Fourth one and second one. Add that's the second one. Subtract the fourth one from second. 2 minus 4, that's v2 minus v2 with the cancel. 4v1 minus v1, that is 5v1. That's 8 minus 12, it is minus 4. So the v1 equals minus 4 over 5, the meters per second. And using one of the equation here, that's v2, that's let's say the fourth equation you can use. That's v2 equals then 12 plus v1. So that's 12 plus v1 is minus 4 over 5. So common denominator is 5, that is 60 minus 4 is 56. 56 over 5. So that is 11.2 meters per second. And this is minus 0.8 meters per second. So So these are the velocities after collision. That's a v1. The first body will return back. After the collision, it moves opposite way, and the second body will move the same direction. Okay. හරි නේද මං අර ඉස්සල්ලා ලියද්දී ඔය එහෙට මෙහෙට දාන රින මාරු වෙලා තිබ්බේ. දැන් හරි. Is it clear? Oh, නෑ නේ සද්ද. Good. All right. Then let me second one. Can බලන්න second one කොහොමද කරාද ඔබ? මේවනේ දියන්නේ මම මේක මෙහෙම කරන්නේ නැතුව ඔයගොල්ලෝ හිතන්නේ මේක රෙන් සුළු කරා කියලා මේ දශම ගණන් දාලා මේක v1 square plus v2 square. එතකොට මෙතනින් මොකක් හරි v1 එක හොයලා අරකට සබ්ස්ටිටියුට් කරනවා. එතකොට quadratic equation එකක් v1 එක you can to solve it. ඇත්තට මේක එතකොට answers දෙකක් එනවා. එකක් වෙන්න බැරි එකක් එනවා අනික වෙන්න පුළුවන් එකක් එනවා. හරි. ඉතින් ඒක මේ ප්‍රැක්ටිකල් නෑ ඒක ඩිෆිකල්ට් දෙන්න. එහෙම සුළු කරනවට වඩා ලේසි විදිය තමයි මේ විදියට අරන් සුළු කරන්නේ. Alright. Okay, let me know the second. I'll do the second bit. Can I erase the board? Alright, I'll erase this all. Now the second one. They given there's two bodies, this B and C, and this A will move the velocity V. Let's consider the first case, right? Actually in this case, let's say the mass of each one M. What is the initial momentum? That is mv only in this direction, right? The momentum is mv, and the initial kinetic energy. Kinetic energy before the collision, it is half mv square. Right. So then now we need to check if it is a elastic collision. So then what happened? The kinetic energy should be remains constant. That means the same kinetic energy obtained after the collision also, and momentum also should be conserved. So then the first case, let's say the A remain there, and B and C is moving. If they are given as a V over 2. There's a mass M, the B and C. And what is the momentum, final momentum in this situation? That is mass 2m there multiplied by V over 2. That's mv. Wow. What's happened? Momentum is conserved, right? But can we say that is this collision is happened? No, because another condition should be there, because they given that collisions are elastic collisions, because this smooth pace, no energy loss. So if the collision is elastic, they given it, right? And then find the kinetic energy after the collision. Two masses moving into, that's a half 2m mass multiplied by v over 2 square. So after simplification, that's 2 cancel, that's 4. This is mv square over 4. So this is less than the initial kinetic energy. So this is not the elastic collision, because some kinetic energy will lost. So this, the Ke final is less than the Ke initial kinetic energy. So this is not the elastic collision. The energy, kinetic energy is not constant. Okay, then you can say that this Ke is not constant. So this cannot be happen. This cannot be happening. The first one cannot be happening. Then let's see the second one. Second one, they given like that's two bodies remains stationary, A and B, and C is moving with the velocity v. So after the collision, the momentum is conserved, that's mv, and after the collision, the kinetic energy is half mv square. So that can be happen. That's the kinetic energy is also conserved, and momentum is also conserved. So this can be happen. This can be happen. Also we need to check third one. If after the collision is all move with the velocity v over 3, what is the final momentum? That's 3m mass, and velocity is v over 3. The momentum is conserved in this case also. Momentum conserved. But what's happened? The kinetic energy, the half, the 3m is the mass, velocity is v over 3 square. Squaring of this, that's v square over 9 divided by 3 into 6, that is mv square over 6. That's also less than the initial kinetic energy, so this cannot be happened, right? Yeah, no, this cannot be happen, and this one can't be happen. Only the second case will be the probable situation there, right? Then over MCQ questions are pictures which the way of their moving after the collision scale. You need to check like this. Momentum conserved and energy, kinetic energy, that's only for the elastic collisions. Right? Is there any doubts? Okay. Then write the third question. A gun is mounted on a railroad. A gun is mounted on a railroad car. Railroad car. The gun is mounted on a railroad car. Railroad car. The mass of the car, comma the gun, the mass of the car, comma the gun, and the operator, mass of the car, the gun, the shell and the operator. The shell and the operator is 50 m. Is 50 m. Right, where simple m is the mass of one shell. Where simple m is the mass of one shell. Shell. Right, if the muscle velocity of the shell, if the muscle velocity of the shell, is 200 meters per second, what is the recoil speed? What is the recoil speed of the car after the second shot? After the second shot, you can neglect the friction. You can write this, neglect the friction. this shell has a mass m, and with all the others has mass 49 m. The total is 15. Total 50 can shell like there's a mass of the other remaining parts without the shell is m, right? This given as is moving with the velocity 200 meters per second, and then it's recoiled after first shoot with the v1. The v1 you can write as the v1 is the that's the velocity of the car after firing first shot, right? After firing first shot. Okay, then you can find this v1. Apply the linear momentum conservation to this direction. Before the collision, before the firing, so this all the momentum is 0. After the firing, the momentum of the smaller body, that's mass multiplied by 200 meters per second in this direction, and we are considering this other part is 49 m into v1. The v1 I will get at the direction, but I am not going to put the sign here. v1 we need to find it. So mn cancel. So v1 is 200 minus 200 divided by 49. That means this moves backward. It's negative value we get. Okay. Then we write that after first firing, first shot firing, right? To first shot firing, we'll take that velocity of the shell with respect to ground. Velocity of the shell with respect to ground, that is 200, right? That's, you can write then with respect to ground, that is v of shell with respect to ground, that's earth, that's equal to v of the shell with respect to the car plus v of the car with respect to the ground. So this is given as a 200. Shell with respect to the cart, how you can write the shell velocity with respect to the cart? That's we need to find then, right? This means that's a shell. I am writing this v shell. This is v shell, and this cart with respect after firing. This the velocity is there, right? This 200 or 9, because this in this direction is negative, and the backward direction is positive. So then you need to put it as a negative sign, right? Considering this all in this direction, that's why I'm writing like this. A little get strong is the 200 is the velocity of the shell with respect to the gun, right? Gun means there's a car, because a car relatively So this should be with respect to the car, and then it's equal with the shell with respect to the earth plus the earth with respect to the shell car. Very well that one. So this is the 200, and this you need to find that velocity of shell with respect to earth, because the momentum conservation we can apply for the with respect to the same frame, right? That frame we consider as earth or ground. Make then it's equals to the minus VCE. That's a car with respect to the earth. This is the value of this. So then it's become positive. Minus made the minus 200 divided by 9, 49. මේ පැත්තට එතකොට shell velocity එක හොයාගන්න. මොකද part එකට related 200 වලින් එළියට ඇති. Now this 200 minus 200 over 49. One in 200 එළියට ගත්තොත් that's 49 minus 1 48. This 48 divided by 49 into 200. This is the velocity of the shell with respect to the earth after first shooting. Because for the second shooting, before we go into the second shoot or second firing, you need to know about this velocity, because now there's a initially there's a now momentum. So now we apply this previous case conservation of linear momentum for the second shoot. Then write using linear momentum conservation after second shot. Then the initial make up then bullet එක දැන් යාලා ගමන් this is mass m multiplied by this velocity v shell. It's 48 and 49 200, and other parts are remain 0. Actually not remain 0, no, because it's more to this side. මේකත් මේ ආයෙ පැත්තට. It's more to the opposite side. හැබැයි බුලට් එකේ velocity consider කරලා ඇති වැඩක් නැහැ නේ. මේ බුලට් එක මේ velocity එකෙම යනවා. After collision උත් ඒ first bullet එක එහෙමම යනවානේ. So you don't care about the first bullet. Only the gun එක consider කරගන්න. gun එක move වෙන. It's moves to the backward, so it's minus 49m multiplied by its velocities. This is 200 over 49. ආයෙ ඒකට නෙගටිව් දාන්න එපා. ඒක ඩිරෙක්ෂන් එක අරන් තියෙන්නේ. මම මේ පැත්තට නෙගටිව් දාලා තියෙන්නේ. හරි. මේ නෙගටිව් කියන්නේ බීකම තමයි. So after the collision එක bullet එකක් එළියට ගියා. So bullet of mass m with the velocity 200 is moving. Then ඉතුරු වෙන්නේ gun එක 49m. This velocity, let's say now it's v2. ඒක තමයි හොයන්නේ. Now this is not 200, right? Why? Its velocity is now the shell velocity with respect to the ground. So it is v shell unit. After first shooting, the shell velocity you need to put there, not the 200. 200 is the velocity with respect to the card. So this is the velocity with respect to the earth. Because these all the other terms we are writing there with respect to the earth. Is it that is keep in mind that if you don't know, you write there when applying the momentum conservation. This all the velocity should be with respect to the same frame of reference. So normally we consider it as earth. All the velocity should be with respect to the ground or earth or common frame when applying the linear momentum conservation. That's why I find this value. But you remember that's a question we done. As a river bank is there and the boat is there and the dog is there when the dog is moving to this direction. This is actually similar like that. In that case also we consider the velocities with respect to the earth. Okay, now you know these values, you can substitute. This m will cancel, and then this is 49 and 49 will cancel. This minus 200 there, and the V shell is 48 over 49 times 200, and this is 48 V2, then V2 equals minus 200. We can take minus out, and this is 1 plus 48 over 49 divide by 40. The velocity again. So that velocity is equals to then minus 200 1 over 48 minus and plus 1 over 49. Oh man. සුරු කරලා ගන්න මම සිප්පර ගන්න යන්නේ. ඕක තව බුලට් එකක් ගියා නම් මේක 47 වෙනවා. ඒක 1 over 47. මේක ඔහොම එකතු කර කර යන්න පුළුවන් බුලට්ස් ගොඩක් ඒවා. හරි. If you couldn't understand, let me know. I will explain it. So this is the case you need to know, that which is apply this linear momentum conservation after second shot with respect to the ground. All the velocities you need to consider with respect to the ground, not with respect to the cart, because they are 200 meters per second. That means they are shooting on the cart. So on the cart. So then those velocities are with respect to the cart. Right. Right, the fourth example. Let's write another example then. Right, yeah, the 3 balls ABC. Okay, write the 3 balls, capital A, capital B and capital C. 3 balls A, B, C of masses 2 kilogram, 4 kilogram and 8 kilogram respectively. That's 3 balls A, B, C of masses 2 kilogram, 4 kilogram and 8 kilogram respectively move along the same straight line. Move along the same straight line and in the same direction, and in the same direction same straight line and in the same direction with velocities 4 meters per second, 1 meters per second. Velocities 4 meters per second, 1 meters per second and 3 over 4 meters per second. 3 over 4 meters per second. Then write if A collides with B and subsequently B collides with C, if A collides with B and subsequently B collides with C, show that the balls A and B will be brought to rest A and B will be brought to rest by the collision which will take place and assume the collision is elastic. Right, I will tell the equation it. 3 balls A, B and C of masses 2 kg, 4 kg and 8 kg respectively move along the same straight line and in the same direction with velocities 4 meters per second, 1 meters per second and 3/4 meters per second, 3/4 meters per second. So then if A collides with B and subsequently B collides with C, A collides with B and subsequently B collides with C, show that the balls A and B will be brought to rest by the collision which will take place. You can assume all the collisions are elastic. So this is moving the 3/4. This is moving the 1 meters per second. This is moving the 4 meters per second. They are moving like this. The masses are given like 2 kg, 4 kg, 8 kg. They ask you to write after the collision what are the velocities of A and B. This is before collision. And after say this is V1, this is V2 and this is V3. You cannot consider this all together. To consider this first A collide with B, then what's the velocity of B after this collision, and then B collide with C, then collision. You consider these two all collision not at the same line. Separately consider the collisions and then write. All are elastic collisions, you can remember that. If elastic collision, you can consider that one theory we discussed, that is a velocity of approach equals to the velocity of separation. And clearly you can use that also. Right, let's see. If you got the zero velocity, it's okay. If not the zero velocity you got, let's see the medicine, right? And we have to discuss another one. Yes. Then. Let's first consider collision between A and B first. Right. This is the collision between A and B. A and B. And then apply the momentum conservation, that's area momentum conservation. I'm applying in horizontally. Initially this kind of momentum is 2 into 4 plus 4 into 1, and after the collision the momentum of A is mass is 2 kilogram into V1 plus mass is 4 kilogram for B is V2. Then by simplifying you can write this divide by 2, V1 plus 2 V2, that's equals to the, that is 8 plus 4 6 divided by 2 is 6, then 12 divided by 6, 2 is 6, then the first equation get like this. Right, these elastic collisions then can apply, then the kinetic energy remain constant. So then half 4 into the 2 into 4 square, the sum of the half 4 into 1 square, that's equals to the half 2 into V1 square plus half 4 into V2 square. And using this equation I'll take another one, that is let's say first one, this is another one. I'm take make a simple condition, make me පැත්තට ගන්න, මේක එහා පැත්තට. So that's so take out 4 minus V1 then මෙතන ගත්ත 4 එළියට, that's 4 plus V2 minus 1 then. Still I take as a second equation. මෙතන මේ half 4 cancel, half. Then take this part to this side and this one to the other side. මෙතන 2 4 square තියෙනවා, මෙතන තියෙනවා 2 V1 square. You can take 2 out and then you can have 4 square minus V1 square. මේක මේ පැත්තට ගියාම 4 you can take out, that's a V2 square minus 1 square. Third one. This third one divided by the second, and this is 2 4 square minus, this is you can write now 4 minus V1, that's 4 plus V1, divide by 2 times 4 minus V1. The other side 4, this is also difference of 2 square, the V2 minus V1, V2 minus 1, V2 plus 1, let's divide by the 4 times V2 minus 1. So easy to simplify this, then cancel this 4 and 2, that's 4 plus V1, that's equals to the V2 plus 1. and by simplifying you can say this is v1 minus v2, that's equals to the minus 3. That's another equation, that's fourth one. Then by this 1 and 4 equation you can simplify over v1 and v2. So right after this, here there's 1 and 4 equation. How you get it? That's let's say 1 minus 4. Make adukan, the v1 cancel. This is 3v2 minus v2, that's 3v2. This becomes the 6 minus 3. It becomes 12. No, sorry, 9. So v2 becomes in 3 meters per second. If this is 3v3, then this 2 into 3 is 6, and this v1 becomes 0 then v1 is 0. So one thing is okay, proves then after the collision a becomes rest, that's a velocity of a becomes 0 then, that's okay. Then go for the second collision, that's collision with B and C, the collision between B and C then, right? First you copy down up to this point. If you finish in the right place, I'll just this as the collision between B and C. Now I change this order, the momentum conservation applied to this direction. Now this part already no, after the collision I'll write this is now becomes 0. I will write this now, I'll change this figure now. This v1 becomes 0. This is moving with the velocity v2, that is the 3 meters per second, right? This velocity. Now this is velocity, this one is already there, so this is 0 now. So this lay the velocity, this is v3, sorry, v3 is already there, this v2 dash I am taking, sorry, it's v2, no, after the collision it's v2, and this will be v3. let's see then edena venamane after collision. Okay, then the linear momentum of this, that is 4 into 3, this one is 8 into its velocity 3 over 4, and this is 4 into the sum of taking v2 dash here, and now it's 8 into v3 now, right? So by simplifying this also, that is 12, make capital, so 2 is 6 and 18, and make a decaying bedwork, 18 inside is 9, and this is 2v dash, 2v2 dash, and this is 4v3. It's become right. I'll take this equation as a calling 1 2 කියලා ගත්තා. ඒ වෙන අකුරු ටිකක් ගන්නවා. හරි. දැන් මෙතනින් අර වගේ සිම්ප්ලයි කරලා ගන්න පුළුවන්. You take this side to this side. There's a 4. This is then become 3 minus v2 dash. And මේක ගෙනියන්න මේ පැත්තට. ඒක 8 එළියට ගත්තා හැකි. This v3 මේ ලියන මෙතඩ් එකට කරන්නේ මේ සිම්ප්ලයි ගන්න ලේසි වෙන්න ඕනේ. නැත්නම් it's much difficult to simplification, right? It's a b. So the kinetic energy is also constant there. The kinetic energy of the b is 4 into, now it is moving with the 3 meters per second, and c has the mass 8 and its velocity is 3 over 4, that's square of that. And after the collision, this is 4 into v2 dash square, and this 8 into v3 3 square. Right. Then similar way I'm considering a half cancel. The mass 4 mass me 4 take out, then this become 3 square minus v2 dash square. After mass 8 into v3 square minus 3 over 4 square. Similarly, that's the equation C then. The C divided by B then. Then 4 කියලා මෙතන එනවා 3 minus v2 dash 3 plus v2 dash. මේ පැත්තේ බෙදන්නේ 3 minus v2 dash. This side 8, the v3 minus 3 over 4 is v3 plus 3 over 4, and here 8 v3 minus 3 over 4 there. Now also you can cancel this, and remainder is 3 plus v2 dash, that's equals to the v3 minus plus 3 over 4. PV terms come v2 dash minus v3, that's 3 over 4 minus 3, that is 3 over 4 minus 3, 3 minus 2, that is minus 9 over 4. That's equation number D. Okay, now this equation A and D you can solve to get the result. මේක එච්චරම එකපාර බලලා එහෙම යමී කරන ලියලා ඉවර කරන්න පුළුවන් ඒවත් නෙමෙයි. You need to think a little more. Then the first equation you have this, second equation you have this. In it's easy, the A at 4 times D, multiply the D by 4 and add to the A. So if it is multiplied by 4, this become minus 4v3, this is plus 4v3, cancel, and then this is 2v dash v2 dash, and here is multiplied by 4, it is become 4v2 dash, and this 9 minus make a 4 is minus 9, they cancel. So then v2 dash equals to 0. That's the velocity after the collision, velocity of the B after the collision, it's 0. And then v3 you can find by substituting this value here. This is 0. If this is 0, this v3 equals minus 9 over 4, that means v3 equals minus v3 equals minus 9 over 4, the v3 over 9 over 4, that's 2.25 meters per second. That means after the collision, the C, only the C is moving, all the other two bodies stop their motion. That make it මෙහෙම හිතන්න, මේක හරි මේ equation එක. මේක මේ values මේ masses චුට්ටක් හරි එහා මෙහා වෙනස් වුණොත් මේ බෝඩ් දැන් හිතුව මේක දැන් C ගිහලා B වැදුණා කියලා මෙහෙම B එනවා. B නතර වුණේ නැතුව B මේ පැත්තට කොලයිඩ් වෙලා ආවොත් ඒ masses අනු වෙනස් වෙනවා. C has a larger mass තිබ්බනම් මේ B අනිවාර්යෙන් මේ පැත්තට එනවා. එතකොට මොකද වෙන්නේ? ආයෙ නවත්තන්න බෑ දැන් ආයෙ calculation එක කරන්න, because then A B comes and then it's collide with the A stationary in A ගේ ආයෙ collide වෙනවා. ඒවල ආයෙ ඒක collide බලන්න ඕනේ. ඊට පස්සේ නිකන් හරි හිතන්නකෝ A ගේ වැදිලා B ආයෙ අනිත් පැත්තට ගියා කියලා. ඊට පස්සේ ආයෙ බලන්න ඕනේ ඒක ගිහිලා C ගේ වදිනවා කියලා. එතකොට මොකද C ගේ වදින්නේ අර එයා C යන velocity එකට වඩා වැඩි velocity එකකින් විතරයි. එතකොට මේ collisions කියන ඒවා එහෙම මේ එකපාර හදලා ඉවර කරන්න බෑ එහෙම. You need to consider that one by one, you need to consider. Right? නිව්ටන් කාර්යය කියන එක මම ඔයාලට එක දවසක් ඔයගලන්ට පෙන්වුවා නේද? නිව්ටන් කාර්යය කියලා එකක් පෙන්වුවද නැද්ද? කරලා ඒකේ කොහොමද කොලයිඩ්ස් එන්නේ කියලා ඔය ඊක්වල් මාසස් කොලයිඩ් වුණත් එකක් නතර වෙලා අනිත් එක කොහොමද යන්නේ කියලා පෙන්වුවේ නැද්ද? මතක විදිහට ලියාගන්න එකක් නතර වෙලා අනිත් එක කොහොමද යන්නේ කියලා පෙන්වුවේ නැද්ද? Right, you can see that I will show you the simulation for this one. Then this is the way you can write it. So there are two masses. That's blue color one has a 0.5 kilograms, other one 1.5 kilograms. So larger mass, right? So we can change the mass using this bars. And first I play you the simulation. Okay, this collide and then this moves to this side and this collide and then come back, and then again it collide with this and then collide. So like that, these collisions are not stopped then, right? You can see here, right? If you, let's see what's happened when the masses are equal. So I will stop first, right? So if we consider that's both masses I'm considering as 1 kilogram. Right, then this reflecting water aerosols, that's momentum. The elastic, that 100% elastic collisions I'm considering. So let's see now, these masses are equal, then what happens? Okay, then this both balls are moving, it's a opposite direction, right? I'm considering that one is moving the other direction. This we can change it. All right, let's see now. Oh, sorry. I have to change the velocity, that's why. This velocity I reduce this 0, right? Now no velocity is there. And so you can see then this is system that initially if that one has the more velocity, this is moving with that velocity. Remember that. Make a velocity का 0 में करो. Then when they collide, so this will stop and this is moving with the velocity coming with the other one, right? So this, if the masses are changed, you can see now. If you can use another one, so may api then karawagi, you can consider the masses, the velocities. ඊට වඩා වැඩි කොහොමයි consider කරන්න පුළුවන් you can with this one. The masses also you can consider this first one as a smaller mass. එක range එකක් තියෙනවා mass වෙනස් කරන්න මම මේ නිකන් පොඩි වෙනසක් විතරක් කරන මේ වගේ right second body just this one and then you can see that how they collide and they move. Constant size also you can consider, and then මේක වෙනස් කරලා බැලුවා හැකියි. හරිද? මම නිකන් පොඩි simulation එකකට you can consider it for the two dimensional motion, that's oblique collisions, how they happen. මේ වගේ තමයි gas එකක් ඇතුලේ වෙන්නේ. And also if inelastic collision, that's some kinetic energy is lost, you can see that they contact together and moving like that. So all things you can discuss like. I'll send you this link for this simulation. You can go to it and then check whether what you can do. Phone එකෙන් කර හැකි, mobile එකෙන් you can go through it, right? So I'll send you the link for these simulations because it's much helpful to understand the motion and also understand what's happened after. If you have got to the questions to do, then you can model the question with this simulation. You can එකේ තියෙන values එක proportionality එක අරගෙන බැලුවා හැකි මොන වගේද වෙන්නේ, කොයි විදිහටද collision වෙන්නේ, mass එක වෙනස් කරාම කොහොමද වෙන්නේ. It's more helpful you to get an understanding, because in this better thing is that to get the understanding, the perfect clear understanding about the question. So you can get that is by using those simulations, because these are not the one developed by the students, those are the one developed by the University of Colorado University. They use these simulations, right? They in education theories all the way they have this කියනවා ඒගොල්ලෝ මේ ඒවා use කරන්න කියලා. එතකොට මේ get the more understanding about this. There are so many simulations for different sections, different fields, different lessons වලට තියෙනවා. මම කලින් උතකලන් පෙන්නවනේ ඔය වගේ කීක. ඔය collisions, equilibrium වලට. ඒක සමහර ඒවා දෙනවා මේකේ නම් තිබෙන්නේ නැහැ. පොඩි games වගේ හදලා තියෙනවා ඒවට ඒක නිකන් values දාලා ඒක game එක දිනනවා කියන්නේ you need to know about the physics. Physics හරියට දැනගන්න ඕනේ. ඒක නිකන් කරලා පාට win කරන්න පුළුවන්. අපි තව එක question එකක් කරමු. That's relating to the two bodies in contact together after the collision, right? For the perfectly inelastic collision. Then right there, after this question I will stop the class for today. The right there, the two bodies of masses 1 kilogram and 1.5 kilogram. Two bodies of masses 1 kilogram and 1.2 kilogram are moving with the velocities 2 meters per second and 1 meters per second, respectively, as shown in the figure. As shown in the figure. After the collision, they stick together and moving as a combined body, as a single body. After the collision, they stick together and move, stick together and moves as a single body. Find the kinetic energy lost after the collision. Find the kinetic energy lost after the collision. And then what's happened to this loss of kinetic energy, and explain what happens to this kinetic loss of kinetic energy, right? You need to explain that's what happened to this loss of kinetic energy. Right, because even it's a, this is this kind of, as we consider this as a perfectly inelastic collision. This is perfectly inelastic collision, right? In any kind of collisions, the momentum conservation is already holds, right? The momentum conservation can apply, only the kinetic energy conservation you cannot try. Here then you can apply the linear momentum conservation towards this direction, 1 into 2 plus the mass 1.5 kilogram into 1 is the velocity, because this is writing right m1 v1 plus m2 v2, and this is the total mass is 2.5 kilogram multiplied by, let's say, its velocity v, this v velocity you can find now. This is 2, this 1.5, 3.5, this 3.5 divided by 2.5, so that is 7/5. This means is 1.4 meters per second. Then the kinetic energy before the collision, right? Ke before collision, the Ke I am writing, right? It is half into the mass 2. So the mass is 1 and the velocity 2 square plus half into 1.5 into 1 square. So then it's 2 cancel, this 2 then 0.75, that is 2.75 joules. Then kinetic energy after collision, that is half total mass 2.5 into the velocity 1.4 square. වැඩි වෙයිද මම කලින්ට වඩා මොකද මම මේක ඉතරනේ දුන්නේ බලමු. The 2.45. So therefore kinetic energy loss is KE loss, that's equals to the initial one minus final one. Make a final minus initial කියලා ලියන්න එපා. මොකද loss එකක් වුණාම final එක කොහොමද අඩුයි. හරිද? ඉතින් initial loss, initial minus final. So this 2.75 minus 2.45, so then is 0.3 joules. This much of energy is lost. So what happened to this energy? I need to explain this. This energy will convert to the heat or sound, because then when they collide, they can produce sound and also they can produce heats. Yeah, so then you can write there. This energy converts to heats and sound. Right? Okay. This energy conservation and momentum conservation, these collisions and there's all the friction and everything, they can combine together to do the very this for a essay question we can it's all can combine together and you ask a question, right? So I will give you the next questions related to those things then. By combining this all together, in mechanics question normally given like that, not related to the only single part. හැම part එකම එකට combine වෙලා දෙන්න. සමහරලාට one part is from linear motion, other part is from angular motion. Separately දෙනවා නම් ගොඩක් අර ඔය අන්තිම කොටස hydrostatic and fluid dynamics කොටස එක තමයි වෙන් කරලා දෙන්නේ. In the appear C types questions discuss කරමු ඊට පස්සේ ඒ විදිහට combine කරමු. So next week I will start I try to start the angular motion parts and then I'll give some paper for you, because most of these course they are going to do the term test examination. So then next week I will give you this term test exam, small exam, right? So you can write and then because actually in the class I'm not given that. I'll send you the paper before the class, so then you write and then come. නැත්නම් මෙතන මම බලන් ඉඳලා බොරු වැඩක් වෙනවා. බලමු next week එකේ මම ඔයගලන්ට message එකක් දාන්නම්. physically පටන් ගමු අපි පුළුවන්. මේ පාඩම ඉවර වෙනවා ඉතින් ඉවර හින්දා angular motion පාඩමේ ඉන්න physically. ඔයාලට බදාද හවස මාරියෝටත් පුළුවන් නේද? බදාද හවස අර නිත් එක්කනට පුළුවන් කෝවා වෙන්නේ. රවීෂට පුළුවන් කෝවා. So I'll try to make a change. I'll confirm it. I'll send the message in the WhatsApp group. If you can reply me, right? If you can change, we can try to change. If not, we can do the class and do this. Okay. මොකද අර එතන පොඩි ගැටලුවක් එන්නේ මේ. After the schools, when I come to that hall, it takes some time. බලමු ඒ වෙලාවට ඉස්කෝලේ යන්න ඉන්න පුළුවන්. ඉතින් ගැටලු කීපයක් තියෙනවා. ඒක හරි ගියොත් මම I'll put the message, right? message එක දැම්මේ නැත්නම් අපි මේ විදිහටම කරමු ටික දවසක්. මොකද මට මේ පොඩි ප්‍රශ්නයක් තියෙන්නේ මේ පාර A levels එනකම් තමයි. A levels ඉවරනාට පස්සේ any date we can change to any date. ඒකට මම ඔයගලන්ට කොහොමද practicals discuss කරන්න ඊට පස්සේ නම් ගන්නවා. ඒකට මම වෙනම practical session එකක් කරන්න හරි වෙන time එකක් හරි දා ගන්නවා. හරි එතකන් අපි මෙහෙම කරගෙන ඒකට අපි ටිකක් මේ පාර A level batch එක ගොඩ වෙනකන් මුකුත් කරන්න අමාරුයි. මොකද ඒගොල්ලන්ගේ classes තියෙනවා මේ කෝල් කරන්න බෑනේ ඒකයි. හරි එහෙනම් අපි next week discuss කරමු ඒක ටික. ඔයාලට any questions තියෙනවා නම් ඔයාලා අහන්නෙත් නැහැ, තියනවත් නැද්ද දන්නෙත් නැහැ. You send all the questions to me. මම ලියලා answers එවන්නම්. එහෙම තියෙනවා නැත්නම් පන්තියේදී හරි discuss කරන්න if you have any doubts, any questions related to this. Now you can go through all past papers. I will send you some past paper and yes. අවුරුදු ටික එවන්නම් මේ එක එක questions related තියෙන. Go through those past papers. නැත්නම් මම I will do it as a tutorial. එකක් විදියට ඒ questions එක දාලා දෙන්න. එකපාර මම ඔයගොල්ලන්ට physically පටන් ගත්තොත් I can give the tute. If not I will post it. අපි එක මොකද්ද කියලා බලමු. මම ඉස්සරහට කියන්න මොකද්ද කරන්නේ. Okay, I'll stop the class now. So then thank you for the participation. Good night and God bless all. Till once a night.